Hey guys, so in this video, we will learn about panel data in R programming. We will work with a small data set and try to actually get some results based on our panel data. So before starting with the panel data, let me give you some theory of panel data, what exactly it is and how it differs from cross-sectional. So if I talk about cross-sectional data, that is for a particular year basically. It does not have the entity and the subject different. So if I write how exactly it looks like, there is independent variable and dependent variable for I equals to 1 to 2n. So that is what cross-sectional data. There is no involvement of time since it is only for 1 year. Now let's come to panel data. So when I talk about panel data, there is an involvement of the entity which is I here. It could be country, it could be firms, and there is also involvement of time because we are taking data in periods of time. So if I write panel data equation, it will look like something like this. So I'll just write panel data first, and it looks like something x, I, and t is also involved. So this t will also vary. So I can say I equal this should be this 1 2 goes till n, and I also have t which actually goes from 2 to n. So basically, at least it should be greater than 2 or equals to 2, and then from there on, it can go to as many years as we want for panel data. And now the important thing to remember is I is subject here and t is time. Why this is important to remember? Because there is no t involved here in our cross-sectional data. Since no t is involved, we get to know this is only for a particular year and not for more than 1 year, like the way panel data is. Another thing to remember is sometimes it happens that panel data can be longitudinal. And what exactly it means? It means it is collected over time. So I'll write collected over time, and it is collected with the repeated observations. Okay, so the subject remains the same. It does not change the subject. So someone was interviewed 1 year before, and that same person is or community is interviewed again and then again over different time periods, and that data when collected, it can be said to be longitudinal. Generally we use longitudinal to actually measure changes. So what exactly the change has come over the period of time in a particular community. Alright, let me take you to my desktop now and we start working with panel data. I'll just quit this and we'll go to R. So I have a libraries which basically have panel data for us and we'll directly work with that. So first thing I'll do, I'll just call the library AER, and now I'll just run this. Now the next thing is I'm going to get PLM. PLM is basically used for linear programming regression models. So I'll just call that library also, and I'll say PLM. I've already done install.packages for getting these packages. If you don't get this, so you just have to run this command. I'll just write it for you. Packages, and then you have to write PLM. Okay, this will install the package for you. I already have this installed, so I have made that as a command. Now the next thing what I'm going to do is I'm going to import my panel data into R. So the name of the data set is fatalities, and I'll just write data, and here I like fatalities. So I am just calling this data set for me, and here it is. Now I'll just have a look how exactly it looks like. So I'll just click here and we'll see. So if you see here, I have a state and I have a year. So basically this is my I wearing and this is my T. So for different state, I have different years data which has been taken for all these variable, which are spirits, unemployment, income, employment population, and other variables also. Just a quick glimpse to this data set shows me there are no missing values also. So just in case if we have some missing values, my data set get unbalanced. So I'll say unbalanced panel data, which have a different process we'll cover in upcoming videos. And if I don't have any missing value, I have a balanced data. This looks like a balanced data because I don't see any missing value. We'll check with codes also whether we have any missing value or not, but I was just having a glimpse of it. Okay. So next what I'm going to do, I'm going to declare this data set as a panel data. So to declare that, there is a command which is pdata.frame. So I'll say fatalities, and then here I'll write pdata.frame, and it just, yeah, pdata.frame. And here what I'm going to say, I'm saying it is going to be on state and year because those are the things which are getting varied. So I'll write the name of my data set, which is fatalities, then I'll say index it, and you have to index it on your first variable, which is state, and the another one which is year. So I'll just run this, and what this has done, this and told R that this is my panel data, and I'm going to work with my panel data now. Alright, so next what I'm going to do, I'm going to check whether this data set is a data frame, because only when we have a data set as a data frame, then we can start with the manipulation in the data set and make changes to it. So I'll just run is dot data dot frame, and I'll write the name of the data set, and R will tell me whether this is a basically data frame or not. So I'll just run this, and if you see here, I got a result which says true. So it means my data set has been considered as a frame by R. Now what I'll do is I'll try to obtain the dimension of this data set. So I'm going to find out how many rows and columns are there in my data set. So to find that, I'll have to write dim fatalities, and this should tell me how many rows and columns are in my data set. So it says there are 336 observations in total which have been come up as a record, and those data has been collected for 34 variables. So it says basically that I have 34 columns and 336 observations. So with this, I am pretty sure that how exactly my data set has been come up. Now the next thing which I would like to check is what is the structure of the data set, what kind of variables it include in a level factor. So to find that out, I'll just write str fatalities. So I'll just run this. 1 second, I think I have made spelling error. Yeah, I'll run this again. And now it tells me what exactly the variables have been through. I'm just interested into finding out the level structure because I know that in total I have 336 records. So if you see here, I have a factor here at 48 levels, and this is for state. So basically state has 48 levels. There are different states 48 actually states are there, and then the data has been collected over a period of time for 7 years. So if I multiply 48 levels and to year, which is 7, 48 into 7 will come out to be 336. That means the total observation. So it is coming because I have the my I, which is state, getting varied from 1 to 48, and my t, which is time, is getting varied from 1 to 7. All right, let's move on. So the next thing I'm going to do is I am going to see the data set with this command. So this will show me how exactly it looks like. And if you see here, I have some special, like basically the top observations of the data set which have been came up in print, and it shows me what exactly have been all the variables. I can also see here, but just to have a glimpse of only first few rows of the dataset, we use this command, which is head and the name of your dataset. All right. So now what I'm going to do, I'm going to use it to summarize. So I'll write summary, and here I'll write the name of the dataset. Yeah, and then I'll say CN1. So what it does is it tells me that these are the 7 different states which were used, and it tells me the name of these, and then it says other. Okay, so basically these other one is what actually has 294, and this going to be like not many because we have around 48 states. We already saw the level. So data for AL has been collected 7 times, then for the another one, and then this other is for other 48 minus the 6 given over here and those levels. So yeah, that is what it is showing up. Now what I'm going to do is I am going to check whether my data is balanced or not. So for checking balance, the only thing is there should not be missing observations. So I'll say is dot. So basically I'll write a program which will going to check whether it is balanced or not. Instead of me going to check for missing values, this program will do it work and get me the result. So I'll just say fatalities dollar state. So it should start with the state and start checking from there. So it is going to actually look for the length and how many values unique coming up in the state, and then again it is going to check for the length and unique for the dataset fatalities, and this time it is going to check for year. Okay, and now the next thing is it is going to check, it should be equals to number of row, which is fatalities. All right, all right, so that is what it is. Now I'm going to run this, and now I'll say the next thing it has to do is print. Okay, instead of print I should write, yeah, if is balanced, that is what actually the panel data is, then it should give me the result something like this: panel data is balanced, and if it is not, then it should tell me that it is not balanced. So I'll just say, I'll copy this first, and here I'll say else, and this else command I'll write the same panel data is unbalanced. Okay, so I'll just run this now, and it says panel data is balanced, which we saw earlier also with the glimpse of the data that there were not majorly missing values. So this is actually checking row by row. With each cell it is checking for. Okay. Now what I am going to do is I am going to define the fatality rate. So if you see here in my data set, I have population also, and then I also have fatality. So what I'm going to do is I am going to give it a value, and then we will move further with the estimation part of this. We'll subset the data, run regression, and then see the results. Okay. So let us define the fatality. In order to define the fatality rate, I'll write fatalities, and I'll just say fatal underscore rate. So basically I'm creating a new column which is going to be fatal rate. Right now there is no column with this name, and then I'll say fatalities underscore fatal, and this is the existing fatal column which is in the data set. I'm going to divide this with the other column which has population in my data set, and I'm going to multiply the result with 10,000 so that I have the fatality rate which can be expressed per 10,000 people. Now I'm going to run this, and 1 second. Okay, I just made a small error in the spelling, so just give me a second. I'll just correct this. Let's run this and see what exactly come up. So I have got this column. If I see my data set back, there should be, yeah, there should be one more, that is fatal rate. So earlier, we if you see the dimension back, we had a 34 around something. Now, if you see here, we have 35 total columns. So I have created one more column. That is how actually you create column in R. Now what I'm going to do is I'm going to subset this data set. So I'll say fatalities 1982, and I'm going to subset this for the data set, that is fatalities for the year, that is equals 1982. So basically what I'm doing is I am creating a new data set for only 1 year, that is 1982. Basically you can say this will going to be only for 1 year, so it is cross sectional. Okay, I'll just run this. Okay, it has to be subset. Yeah, just run this, and I'll copy this and I'll create one more. So we had 7 years, it goes from 1982 to 1988. I'll create. So I'll just write this and I'll just create one more. So now, okay, this should be named 1988. So I'll just run this again, and now one data set is your 1982, another data set will be 1988, which is fatality is 1980. Yeah. So I have my both the data set. Now what I'm going to do is I am going to estimate simple regression model using both the data sets. So basically what we have done, we have worked with the panel data and then we have subset it to a cross sectional data, and now we are going to run simple linear regression on it. So I'll just write fatal 1982 because this is the name with which I have created the data set. Now I'm going to write NM, and this what exactly is the variable which I created, and I'm going to run it on beer text, and I'll say this all is coming from data equal fatalities 1982. So basically fatal 1982 will come have the simple linear regression result for me when I regress fatal rate on BATX, and similarly I'll create it for fatal 1988, and this all is going to come from this data set. So now I have two simple linear regressions. I'll just run this one and I'll just run this one. Now I have the results stored into 1982 Fatal and Fatal 1988 for the simple linear regression. Next, what I'm going to say is that we are going to run a cough test function that is basically used to actually find out the robust standard error for regression coefficient. And we are also going to run cough test with your cough SC. The reason is it will give us a robust covariance matrix. So there might be heteroscedasticity in the data or there might be a violation of any assumption. It is going to address that. And in this case, we are going to guess the coefficient which are basically much more accurate because we are using robust standard error. So this is recommended that when we have LM test and when we want to get the result, majorly in case of panel data when you subset it, it is best to have your robust standard error. So we'll write cough test and I'll write fatal 1982 underscore mode, and we are going to have vcoff dot equal. Now I said we going to vcoff it on SC, which is basically the method, and then I say type, and in type I'm going to use the simple basic type, so I'll say SC1. Okay, let's run this, and it says fatal 1982 cannot be found, which we created here. Give me a second. Alright, so I ran it again and I got the result. I just deleted the fatal 1982 mode because I mistakenly wrote that one. So if you see here, now I have the t value for intercept and I have the t value for this one. This is how actually I can interpret the result, how exactly BRTX is making changes to the fatal rate per 1000 people, and I can get the same robust standard error and result for 1988 also by just changing the year in my code. And now let's see the results. So if you see here, I have a much more higher t value in case of 1988 data collected, which means also if I see the beer tax estimate coefficient, which was 0.14 in 1982, has rise to 0.43, which means that the beer taxes are rising and having a positive impact on the fatal rate. All right, let's try to see this up in a plot also. So what I am going to do is we are going to actually plot this relationship between the beer tax and fatal rate ratio. So and then we can better analyze the result. So I'll just write plot, and here I'll just say x equals s dot double fatalities 1982 dollar beer tax. So why I have written this is because I want x-axis beer tax in 1982 and in US dollars. Okay, so I have written this, and just to have this, I'll just move further and I'll go for now the y. So I'll write y equal s dot double, and I'll write fatalities 1982, and I'll say dollar fatal rate. So basically the 1982 is year on which we subset, and we are actually taking the help of the variables we created, which is fatal rate in this case. Next, what I'm going to say is I'm going to give X label. So I write X lab. Basically, X lab is used to give label to your plot. So I'll say in 1988 dollars, and I'll just put comma here. And next, I'm going to give Y lab. Y lab. Now see fatalities. Basically, I'll say fatality rate, and then I'll write fatalities per thousand people instead of just writing fatalities per thousand. Okay. Yeah. So this is going to be like this, and I'm just fixing up few things here. Okay. So now I'll move to the title. So I'll write main. I'll say what should be the title. So I'll say traffic fatality fatality rates and beer taxes in 1982. Okay. So I'll just delete this traffic word. I don't think it should write. Like, it doesn't look nice to me. Plotting it a bit. And I'll just make this B capital. Delete with the semicolon. Yeah. Now the next thing I'm going to do is I'm going to set the limits for the axis. So I'll say y limit should be see 0 to 4.5. So the graph should be much more nicer and clearer. And next I'm going to say the plotting character, basically the filled circle, should have PCH equals 20. So you can increase this and the filled circle color will change. Uh, and now I'm saying color should be steel blue. So if you see here, I have the results. So it says beer tax in 1988 and then fatality rate in 1 second. It should be 1982 for me because I'm plotting it for 1982. So yeah, now it shows me what exactly for each beer tax has been the fatality rate. Let's add a line also to it in order to see how exactly it looks like. So I'm going to add a regression line to it. So I'll just write fatal 1982, and in this case what I'm going to say is the name of the regression model, and I'm going to write the line width. So I'll say LDWD equals 1.5, and because I want this plot to know actually I am adding a right line, I'll say AB line because that is what the command start for getting a regression line. Now I'm say this should be dark red. So basically the dark red actually shows up and very well on the graph, that's why. So I'll run this, and okay, it says there is a, so basically it says there should be a comma here because this is going like these two are different and R should know that these two are different. So I just add this. Let's run this now. And I have the line. So with the width of 1.5, which shows me a positive relationship between the two, although not very steep. I'll also show you how exactly we can add legend to this plot. So I'll say legend and I'll write top right at the top right, it show me basically the line type. So I'll ty equal 1, and I'll say color. Basically, I'm telling it the color again is going to be dark red for the legend text, and I'll say that okay, I should not forget the comma, otherwise it is again going to show us the same way it was showing earlier. Now I'm going to write the name. So I'll say estimated regression line, and I'll just close this. So let's see how the legends come up. And if you see here, I have got the legend which says estimated regression line. Now I have plotted this basically for 1982, and if I just replicate all these code for 1988, I'll get the result. So what I have done is I have created this, and I'm going to write here 1988. This is again going to be 1988 because I'm going to pick up that data. This is going to be 1988. So basically I'm changing the values everywhere where it is going to be 1988. And since I have written the name as fatalities 1982 and fatalities 1988, it's quite clear that for the particular year it is using the data. So I don't have to worry about actually getting the result for different year. That is how exactly work gets simple when you actually subset the data and add the name in the variable you create for that data. So I think I am done here. I'll just run this, and it says some error. Okay, extra. I'll run this, and I have the result. And this is also extra. Yeah. Okay, I have the result now. So it says I'll just zoom it for you. So if you see for 1988, I have a more steep curve as compared to what I had for 1982 earlier. If I show you that one also. Yeah. So what I had earlier was not that steep, but when it comes to 1988, we have much more steeper result. Alright, yeah. So what we did today is that we worked with the panel data. Then we actually subset it into two different year, which is 1982 and 1988, and then we get the simple linear regression run over there, and we got the result, and we plot that with the regression line. So I think yeah, that is all for this video. I see you in the next one where we work on panel data again. All right, thank you.